Hello, my name is Dan Valamis, and I'm your host for today's Analytics and Data Oracle User Community TechCast. That's going to be starting up right after this introduction. We'll let a few people kind of flow in to the TechCast. Takes a little bit for Zoom to add everybody. As I said, my name's Dan Valamis. I'm president of Analytics and Data Oracle User Community. I've been doing so for a long time, just about the balance of the history of the user community. Just so you know, we'll start off a little bit. We have a great presentation today. Doga Tekin is going to talk about financial crime and compliance, transforming text documents to graphs. We're going to have a brief Q&A afterwards, so please line up your questions that you have on this. Go ahead and advance to the next slide, Doa. We've also included some helpful links. We'll put those in the chat so that you can click on these links on each of those. This is where you can get more information on Oracle Labs itself. Doa will tell us a little bit about that, and as well on Oracle Graph, which Doa is going to be talking about. You can get more information on oracle.com, go to Graph, and also there are live labs specifically on running Graph live labs. So if you want to try this out yourself, you're welcome to. These are virtual machines that are all set up with the software pre-installed, and you can try this stuff out. Also have some more information on Financial Services Compliance Studio. I won't try to read that big long URL, and the Oracle AI language. So next slide, please. So a little bit about Analytics and Data Oracle User Community. We put on these TechCasts. We are a separate, independent Oracle user community. We have the Oracle Spatial and Graph Special Interest Group as a subset of Analytics and Data Oracle User Community as a SIG. And we've been putting on these TechCasts really throughout the pandemic years, and I believe starting even just a little bit beforehand. We have 5 years worth of these TechCasts. We're thrilled to have Doa joining this and presenting on Graph, but we have 5 years worth of these out on our website. You can find more at andouc.org/techcasts. Be sure to look at the replay of the videos, and the slides are there. Indeed, we've asked Doa to supply those slides. We'll have those up on the website soon after the conclusion of this presentation, and we will make the replay available both on our website that you see here at andouc.org/techcasts and on our YouTube channel you can get to from our homepage at andouc.org. So we have a lot of information. Indeed, we ask that you submit abstracts so that you too can present as one of our TechCast participants, one of our presenters. You'll find that link to submit abstract on the TechCasts page. We also have some upcoming ones. On July 13th, Kathy Pendley will be presenting on advancing analytics at Rosendin, a customer presentation where she's talking about what they're doing with Oracle Analytics Cloud. So we're looking forward to that. And as well, on July 27th, we have data science survey results presented by Carl Rexer, and this is my brother, Tim Valamis. Carl has been doing this data science survey for at least 5 years, maybe decades. And he does a survey to find out what tools are people using. Very interesting to hear his kind of expert opinion from an outside on where Oracle fits and what tools various people are using for data science across really the whole world. So we're looking forward to both of those. Next slide. We also have merchandise. And so that's how you can help support the user communities. We've got color changing mugs, notebooks, luggage tags, phone holders, all that type of stuff. So look at the store in andouc.org. So look forward to that. Next slide. We are a user community. So we ask that you visit our website. A lot of the background and a lot of the information activity takes place on our Slack workspace. We welcome all of you to join our Slack workspace. We have a lot up there on our YouTube channel. That's where we keep all the TechCasts. and you can tweet us. We also are on Facebook, LinkedIn, and of course, there's more information on spatial and graph SIG within that as well. Go ahead and go to the next slide. I'll also take an opportunity to talk about our upcoming conference. Analytics and Data Summit 2024 takes place March 19th through 21st of 2024 at the Oracle Conference Center. We were thrilled to be able to do this. You see the picture up there of our panel that took place in Analytics and Data Summit 2023. We had people from all over the world talking about these topics of analytics, spatial, graph, machine learning, and data warehousing, data lake, those types of technologies all took place at the Oracle Conference Center on Oracle's campus. We have a call for speakers that's open. We'd love to have you submit your abstracts for consideration for our March conference. That's now open, and you'll find more information about the conference. You can register an interest in attending. We don't have the actual registration open yet. We're setting prices, looking for vendors, all that type of stuff, and making those decisions this summer. But you can get more information at andouc.org/AMD Summit 2024. I'd encourage you to submit any of your abstracts out there. And with that, that's kind of the background that I had. Anything on the next slide? And I'll transition to introducing Doga. We have Doga joining us from Oracle Lab. We're going to be recording this so you can share this with people. I will with any of your colleagues. I'll also mention at the before I get into this that you can put any questions that you have in the Q&A. If you have general stuff, we encourage you to reach out. We are a community. You can say hello to others on the chat. But if you have questions, please put them in the Q&A widget. It allows us to keep track of what questions are being asked. We do also have members of the Graph Product Management on to be able to ask to answer any of your questions you may have on specifically on Graph on that area. So we're thrilled to have Melly and Jean join us, and they can answer questions, and we'll also pose those questions to Doga at the end of his presentation. With that, let me go and introduce Doga Tekin is a research and engineer at Oracle Labs Zurich, where he works on natural language processing and graph machine learning in various contexts. He joined Oracle Labs in 2021 after receiving an MSc degree in computer science. Go ahead and take it away, Doga.
Thank you, Dan, for the introduction, and thank you all for joining. Let me start by quickly introducing Oracle Labs, if you're not familiar with us. So we do many types of research. We are a research and development organization inside Oracle. One type of research we do is exploratory. So we pursue new ideas within any domain that's relevant to Oracle's work. We also do directed research in collaboration with product teams on difficult and future-looking problems. And this research is driven by product requirements. So this is kind of closer to what I'll be presenting today. We provide some consulting on areas where we have some unique expertise on. And when research proves very useful, we also sometimes grow new products out of that research. So due to the nature of Oracle Labs, my talk today will include both some ongoing research work and also some publicly available Oracle features. I'll try to make this distinction clear whenever it's relevant. So what are we talking about today? I'll start by introducing knowledge graphs briefly and try to motivate why we want to transform text documents into these graphs. I'll give you some related work from the literature about knowledge graph construction and any relevant background. I'll describe our approach in some detail. I'll talk about the data and annotation requirements for this project. We'll look at some numerical results and also do a visual demo. And then I'll also show you one example of how we can use these graphs to fight financial crime. And I'll close it up with some takeaways. So knowledge graphs, these are knowledge bases that use a graph structure to represent information about entities and their relations. Here's a small example knowledge graph about me, where you can see me as an entity in the graph, and you can see where I work as a research engineer. I work at Oracle Labs, which has an office in Zurich, where I live, and I'm presenting in AnDOUC TechCast. So this is a small example knowledge graph. Of course, in reality, we use much larger graphs for much more serious use cases. They're useful for improving search engines, smart assistants, detecting fraud and financial crime, predicting diagnoses in healthcare, and many, many other applications. The reason is that they are performant, they're expressive, they allow us to integrate and unify and analyze data in interesting ways. So that's already quite enough motivation maybe to try to transform text documents to graphs. More clearly, first, it helps us with visual inspection. So seeing this information presented graphically as graphs can sometimes help us see patterns that are easy to miss in text. And also this empowers a lot of downstream algorithms that we might not be able to get with the text. So if you obtain a graph representation, we can apply many graph algorithms and graph machine learning models to achieve downstream tasks that require or utilize this structural information in the graph. And actually, to further motivate it, I should note that Oracle Graph already has a lot of capabilities once you obtain some graphs. So you can detect communities in your graph, you can do topology analysis, you can predict new links and connections between your entities in the graph, you can rank your nodes and edges according to different metrics, you can do all different types of pathfinding, and you can apply machine learning models on your graph. And I should also note here that these graph capabilities are available now in every additional Oracle database, including the new free developer release in 23C. So if I convince you in this talk to play around with some graphs, there's nothing stopping you. So let's get into some use cases for trying to transform text documents to graphs. One use case I'll give you from the literature from 2018. There was a paper that tried to construct a scientific knowledge graph by automatically analyzing abstracts from a journal paper. So we look at the journal and every paper that's published in that journal, and if we try to build a graph out of it, we can actually see what new technologies were presented in that journal, what they're being used for, how they're evaluated, what other things they are linked to. So this might be a way to keep track of scientific developments visually and graphically. Specifically, the use case I'm going to be presenting today is about case graph construction from suspicious activity reports. So this project is a collaboration with the financial services team, who sell a product that let financial investigators and banks investigate financial data in the form of graphs. And financial investigators often need to read these documents called suspicious activity reports that describe certain suspicious events going on with accounts and customers and describe why these things are suspicious. This goal here in this project is about trying to take that text document and build a graph out of it where we can clearly see the accounts, the owners of those accounts and their relations, all the other companies and entities they're interacting with, and who they're sending money to and where they're receiving money from. We want to do this because, as I said, Oracle Financial Services already provides a tool called Compliance Studio that already builds a lot on these graphs. So there's graph analytics for entity resolution, there's interactive visualizations, there are ways to detect complex money patterns and use deep learning to find criminal networks. So we want to empower all of these things, but somebody needs to build those graphs. So this project is about whether we can help that process by building graphs automatically from text documents. So for that, we start with some research. We start with some related work from the literature. So the most popular public dataset for trying to generate graphs out of text documents is the scientific dataset that I presented a few slides back. So this dataset includes 500 scientific paper abstracts that are annotated with entities, relations, coreferences. And these things, entities, relations, coreferences, are what we need to extract to obtain a graph out of text. I'll describe how that works shortly. But when we looked at the literature on this, and specifically this paper, we saw decent results, but we also noticed that since that work, there have been improvements in all of these natural language processing tasks, but there were no frameworks combining these into a new modern end-to-end solution. So that's what we set out to do, and that's what I'll try to present to you today. So what is kind of behind those improvements since 2018 in these natural language processing tasks. But it's mostly transformer models. You might have heard of BERT or Roberta or other transformer models. When we looked at the literature on these 3 NLP tasks, we noticed that the strongest models in all of these domains often consist of just large pre-trained transformer models plus simple classifiers built on top of those. So the goal here was to obtain a state-of-the-art pipeline using these modern approaches. So how does it actually work? How do we actually go from a text document to a graph? I'll try to explain it with an example. Let's imagine this is our text document. This is the entirety of our text document, 2 sentences. One sentence is talking about a person's account and another sentence is talking about their transactions. So step 1 is detecting all the entities in the text. So persons, accounts, dates, companies, these will be the nodes or vertices in the graph. The second step is to detect all the relations. So who owns what account, who sent money to whom, which account opened on which date. These will in the end turn into the edges in our graph. And one final thing we need to solve is coreferences. So often in text documents, the same entity can be referred to by different aliases. So Adam Smith is actually the same person as Adam, or this account number can be referred to later as just the account. But we need to recognize these are the same entity throughout the text so that we can build a unified graph. And you can imagine that if we extract all of this information, it's easy to construct the graph you see above. So the people and the organizations turned into the nodes, the relations turned into the edges. So that's kind of the high-level overview of the approach. We take a text document, we split it into its sentences, a named entity recognition model extracts the entities, a relation extraction model extracts the relations, and a coreference resolution model figures out which entities are supposed to be the same so we can merge those together into a graph. That's the high-level overview. From here, I'll kind of dive a little bit deeper into how each of these steps work. So let's start with named entity recognition. As I just described, this is the task of looking at the sentence or a text and detecting where the entities are and the types of those entities. So from a modeling perspective, one way to approach this is we split the text into its tokens or words to simplify it a little bit. And we need to label each of those words with a special label that tells us if that word is part of an entity and what type of entity that is. So these special labels basically tell us there's a person here, there's an account there, there's a date there, and the rest of the words are irrelevant. They are not entities. So how do we do that? We do that through transformer models, as I said. So BERT is an example transformer model. These models have hundreds of millions of parameters, or these days, billions of parameters usually. And they use those parameters to take in some text and output numerical representations of each word in that text or each token in that text. We call these things embeddings, these vectors of numbers, basically, for each word. And these transformer models are pre-trained on a language modeling task using usually datasets of billions and billions of words. And what that means is they learn to capture information about both syntax and semantics of natural language. So these numerical representations we get out of the text capture all of this information. And what that means is we can actually build a simple classifier layer on top of these embeddings to predict what each word is, whether it's part of an entity and what type of entity that is. And we can fine tune all of this with some labeled data to get good performance. So that's the approach for named entity recognition. Let's move on to relation extraction. This task, as we described, is about taking some text and entities and trying to detect whether there are relations between any pair and what type of relation that might be. So from the modeling perspective, one approach for this, the approach we are using, is taking each potential pair of entities in the text and basically trying to detect or predict if there's a relation between those entities and in which direction that relation might be, because relations might be directed. So we need to see if there's a relation in both directions for each entity pair. So how we do that is very similar to the entity version. We again take a transformer model. We take the sentence or the text along with its entities. We pass it through. We obtain the numerical representations. And then we pool those representations into entity representations. So the transformer gives us word representations, but an entity might consist of multiple words. So we need to aggregate those together into a single representation for each entity. And after we have one representation for each entity, all we need to do is, so if you want to ask the model if there's a relation between Adam Smith and this account, we take the representation of Adam Smith, we take the representation of the account, we concatenate them together and pass it through a final simple classification layer to get a prediction. And again, if we have some supervised data, we can fine-tune this model. And finally, we need to solve coreference resolution. As I said, this is about figuring out any coreference relations between entities. So different versions of saying the same entity's name, basically. So the way we do this, a little bit more convoluted than the others, but still not too complex. The first thing we need to do is to find mentions in the text. So what we mean by mentions is spans of words that might be referring to an entity. So let's take a different example this time. Let's say we're giving in some text to the transformer saying, General Electric said the Postal Service contacted the company. So when we look at different spans in this text, so General Electric is a span, Electric said the is a span, the Postal Service is a span. We want to predict which ones are likely to refer to an entity. So the Postal Service or the company, these are spans of words that are likely referring to an entity, but service contacted the is not likely referring to an entity. So we again use these transformer embeddings to predict which are the mentions in the text. And then the final step, after we know which are the mentions, let's say these are the mentions in that text, we want to try to predict for each mention, are there any earlier mentions in this text that are likely referring to the same entity? And the way to do that is we build a simple neural network, again, starting from the embeddings from the transformer, and we solve a simple network basically to predict which earlier spans are most likely to be referring to the same thing. So that gives us all three models we need to build graphs, on to evaluating them and validating this approach. So we used several data sets in our research to validate the performance of this framework. First, 3 public data sets, one for named entity and relation extraction, another one on coreference resolution on news data. And we also used the scientific knowledge graph construction data I showed to validate the end-to-end model, basically. But that's not enough, of course, because as I introduced, we wanted to build this in the financial domain to transform financial documents into graphs. So we needed to also build a data set for this purpose. For that, we took a bunch of these text documents I introduced to you, suspicious activity reports, about 100 of them, and we had to manually annotate them. So we set up an annotation tool. We marked where all the entities are. We marked all the relations between those entities. We marked all the coreferences. So with the help of 2 subject matter experts, we just obtained a supervised data set for this task. So let's look at some results. On the scientific knowledge graph construction dataset, certainly thanks to using these modern approaches, we were able to improve on the results in that original 2018 paper. But it's important to note, after we were doing this work, there are even better scores now published for individual tasks on this dataset. So from 2022, you can find the better result for named entity recognition on this dataset. But you can see also that the state of the art hasn't moved too far here. And among frameworks that can tackle the end-to-end task, what we built is still quite competitive in building graphs out of text. And if you look at the results on the financial dataset that we built, we see even higher results actually. And our theory for explaining that is these reports are much more structured compared to scientific papers. And the models actually learn to exploit that structure a bit to extract entities and relations with higher performance. And one final thing we validated was, so the natural language processing metrics are good, but we also wanted to check the graph quality metrics. So when we look at the graph, the output from the model versus the ground truth graph, do we actually capture the nodes and edges we wanted to capture? And we found that indeed the high natural language processing performance does translate into high quality graphs from the model. So here's a visual demo where we can input some text, a paragraph or a document, and we first see the predictions of each model. So we see the entities and relations highlighted along with the coreference clusters, basically. And soon after, we can see the graph that's built out of it. We can visualize it. We can interact with it. We can feed it into downstream applications to our heart's content. Also, this demo will be built in Data Studio, which is an Oracle Labs product, but you can also interact with your graphs in a notebook platform with Graph Studio. So I put a link here if you want to check out platforms like this later on for yourself. There are some.
Hey, Doa, if you don't mind, interrupt just to ask a question that came up on kind of the platform before you move into the depth of the demo.
Sure.
Luis asks, is this model multi-language capable, or does it only work in English? And then I'm going to also add, if folks, you have other questions, please put them in the Q&A widget. We'd love to make this very interactive, and we do have people from Graph on the line that can answer, but I thought this would be best for you, Doa.
Yeah, sure. I'm happy to answer that. So we certainly only evaluated on English text. The documents we were working with were all in English, and the pre-trained transformer model we started from was also pre-trained on English data. That said, there are many pre-trained language models that are trained in a multilingual manner, that are trained on 50 languages, 100 languages at the same time. And research shows that those models can indeed be applied in many languages at the same time, especially if you have some extra fine-tuning data in a language of your choosing. So can be extended into multilingual workspaces, but this tool that we built so far is English. I hope that answers the question.
Yep, thank you.
Okay, great. So this is kind of the same demo, just screenshots of it for reading in the PDF version if you're looking at the slides offline. So we can move from those. The next thing I want to talk about is, now that we obtained the graph, how we can use that to fight financial crime. So I already linked to Oracle Financial Services Compliance Studio, and you can see many more ways that they're using graphs to fight financial crime. But I'll give you just one example of something we worked on together. We prototyped together using graph machine learning. So one way to aid investigators in these cases is to find historical cases that are similar to a new investigation graph. So a new case comes to me, it's suspicious, I'm looking at it. This tool can give me 5 most similar cases from our past that we made decisions on. And based on those decisions, maybe I can make a more informed decision in this new case. So how do we do that? We start with our case graphs, past case graphs with nodes and edge properties in our database. We pass those to a graph machine learning algorithm that can learn representations or embeddings of those case graphs. And that outputs those embeddings. And hopefully, if these models are working well, we would expect embeddings of similar graphs to be also similar in the embedding space. And now that we have those, when we get a new case graph for investigation, we can also pass that to the same graph machine learning model, which will also produce an embedding of that new case graph. And after that, all we need to do is compare those past case embeddings with the new case embedding and yield the cases that are similar. Again, these graph machine learning capabilities are also already in Oracle Graph. And these graph machine learning models can learn representations of case graphs, taking into account both the graph structures and also the features of nodes and edges. And you might imagine that different financial crime types actually follow different graph structures and actually follow different graph properties. And with our data set, we were actually able to confirm that. So we took these 100 case graphs of different types of financial crime. And once we learned the embeddings and visualized it, we could clearly see, for example, there's a cluster of funnel account cases there, or there's a cluster of tax evasion cases in another place, or there's a cluster of illegal vehicle exporting in a different place. So this kind of validated that these representations can be used to cluster similar types together. And you can imagine this might be helpful to a financial investigator in their work. So what are the takeaways from all of the things I've been talking about? I think the first, maybe the biggest takeaway is knowledge graphs provide a powerful way to represent and visualize your data. They enable novel analytics approaches, and they can uncover useful insights for you. A reminder that our graph already has all of these many features to help you achieve this potential. And if you're specifically interested in the financial side of things, Oracle Financial Services does use these graph features already to fight financial crime. The second takeaway is we can construct these graphs from text documents automatically by using modern natural language processing techniques, such as fine-tuning these pre-trained language models. The work I presented here specifically is ongoing research at Oracle Labs, but if you're interested in the natural language processing side of things, definitely also check out what Oracle offers, for example, under the AI language services, or talk to us as well. And of course, the final takeaway here is annotating documents is necessary to teach language models your desired graph schema. So we didn't for free get a model that can do this. We had to annotate some documents, and we had to fine-tune these models on those documents. But these pre-trained transformer models reduce the annotation efforts greatly. So if you didn't start from a pre-trained language model, we would have had to annotate maybe thousands, tens of thousands of documents, but we could get away with just 100. That said, this is still important future work for us as researchers to reduce this even further. As language models get larger and they are pre-trained on more documents, the requirements for us to annotate data get smaller and smaller. So that's kind of one of the directions we're trying to take this work in. And that's it. That's the presentation. Thank you for sticking around. Now I'm happy to answer any questions you had.
Great. No, thanks. That's actually really interesting to see this stuff being applied in the real world. One question from Vic is, you mentioned there's manual work involved in with subject matter experts to review the documents first. How many hours of manual work was involved? How much of that can be or is already automated? And if you could give us a sense, this I think gets at the heart of the matter, Doga, of how much, what did this take? How long was this running? That type of thing. Give us a little more insight as to what this looked like in the real world.
Yes. Okay. Yeah, I mean, I don't want to give a cop-out answer, but this depends on so many things. On your graph schema, on the type of documents you have, how complex they are, how different they are, how structured they are, which model you started training from, things like that. But I'll at least quantify practically what we had to do. So as I said, these financial documents we had at least followed some similar structures to each other because they're supposed to. So maybe that helped us a little bit. And we started from a pre-trained transformer model that was already pre-trained on, maybe trillions of tokens of text already. So those were helpful for us. But in the end, we had to annotate about 100 documents. These are like 1-page, 2-page Word documents, basically, you can imagine. And maybe it takes a few minutes to annotate one document. So 100 documents, that's worst case, let's say like 5 minutes, 6 minutes, a few hours, maybe a few days, depending on how much you can spend on it. But indeed, there's some manual work in there to train a model to do something specific for you. I should note here that there are already pre-trained entity extraction and relation extraction models that can extract many types of entities and relations out of the box. Like if you're just interested in detecting detecting persons, detecting organization names, detecting country names, people have already pre-trained models to do those things for us. The manual work starts to come up if you have a very specific schema that nobody has already trained the model for. So here we had some specific financial entities and relations we wanted to detect, and that's why we had to do some extra work to teach the model the specifics of those things. But as I said, it's definitely one of our top research topics to reduce that as much as possible. And it does seem likely that with the new large language models, I'm sure everybody's keeping track of maybe ChatGPT and that track of family of models. they are certainly showing much better performance in learning from fewer and fewer examples. Maybe instead of 100 documents, you might need 10 documents, 5 documents. Maybe you just need 3 documents in the future. That's something to look into for sure.
Okay. And I guess a follow-up to that I was just curious on is, all right, so you mentioned some of these models that are already developed. Is this stuff that comes with Oracle in terms of, I know there's Oracle text, you're also talking about the Oracle AI capabilities. Is this something you download, or do you have to go find those out on the internet for these models? How do you, if you will, find these databases of models that are out there?
Right. I can answer more for the graph, I think. I mean, I'm not 100% familiar with the model catalog of the language service right now, but certainly for the graph, when you're using Oracle property graph capabilities, there is pretty good documentation of what kinds of graph models and algorithms are available to you, their differences, which one to use in what scenario. So they should already be available if you're using Oracle Property Graph. You just need to find which one you need from the documentation and apply it directly in your database or in Graph Studio, wherever you're using it. Okay.
And Gene and Melly, I know we have you on the line. If you want to add anything, go ahead, or just put stuff in the chat. If there's other areas, I know we have a link to documentation that maybe has what people need to get started with this. Also, another question came in, any limitation on data sources? For example, can I source the model from newspapers? What's the limitation on data sources on these?
Sure. I don't think there's any specific limitation. It depends a bit what you mean by sourcing the model from newspapers. So I think newspapers are certainly included in the pre-training process of many of these language models already. So even when you're taking the pre-trained model, it's already seen many newspapers or many books or many pages of Wikipedia potentially. But if your end goal is to work on newspapers, you can certainly take some newspaper documents. You can annotate them if necessary with the information you want to extract and fine-tune a model on any type of data you want. There isn't any inherent limitation to the type of data you can use.
Okay. I know another question came in on specifically on graph, and Mel, you answered that in text, but I'll give you an opportunity in case there's anything you want to add. The question that came in, Doa, especially if you want to add anything, how does the Oracle offering compare to the Neo4j approach in regards to graph database capabilities? Do you have anything to add on that? Melly typed in an answer specifically on that, but anything to add?
Right. I feel like Melly might be able to answer better than me on that.
So maybe I'll just jump in and add to what I said.
Please.
I think the key difference is that we're very integrated with your existing database, or Oracle Graph is. So there's no need to move data into separate silo just to use these really cool capabilities that Doga was talking about. If you have a database, you have your text data there, you have your JSON data there, you have your relational tables there, you can create a graph from all of that right within the same database without having to move your data into specialized databases. So the power of the converged database, I think that's what I would add to this.
Yeah, this is the point that I think so many people miss. Oracle has such a rich history in the relational database capabilities that people don't realize that Oracle Text, Oracle AI, Oracle Graph is all there in the Oracle offering. And this is what I think just is, for some reason, not appreciated as much in the general tech community. So be aware of that. I know, Doa, you mentioned it before. It's there. The graph capabilities are in all the flavors of the Oracle database that's out there. So take a look at it. It used to be cost for free. It used to be an extra cost item. Now it is included with Oracle. One last chance for people. If you want to ask a question, put just a question in there of wait, or something like that. Otherwise, I'm going to look at closing up the TechCast. But really appreciate you, Doga, going into this. I think this would be an excellent type of presentation for our upcoming conference. Really appreciate you doing that. So we ask you to submit on this, and we'd love to see some of this kind of live. I will ask one last question that I'm curious about. Are you looking at actually taking this work and embedding it in? Has that decision been made, embedding it in an Oracle product for the financial services industry from Oracle? Or is this now just something that was a research project, probably related to some customer that asked the question? Where is this going for that?
Yeah, indeed, it's still currently at like a research project stage. But the more we work on this and the more we present it, it seems like the more use cases pop up from different domains, not only from finance, but maybe from healthcare, maybe from support, any other resources. So I think there might be a path for this to turn into something more, but no, I can't really give you anything concrete on that. It's just research and discussions with other teams on how we might use this technology for their purposes.
Okay.
And Dan, if I might jump in, I think I just want to emphasize the point that you made earlier. I think there is still the notion that Oracle database is a relational database, and of course, there's years of lots of innovation going in all the time, and this is just an example of one such effort. Of course, this is and the database and other products as well in the financial services products. So yeah, just wanted to emphasize that once again.
Yeah, that's great. Well, let me take the opportunity to thank you, Doga, and Gene and Melly, for joining us on in this TechCast and talking about a real life example of this coming together with the analysis of the text analytics on here and looking at that with the graph capabilities. So thank you very much for presenting, and look forward to seeing you all. And hey, if you want to carry on the discussion, see us out in the Slack workspace for AnDOUC. If you scroll up on chat, you'll see where you can click on and join the workspace and chat more. So thank you very much, and we'll see you on future TechCasts. Bye.
Okay.